So let's take a look at this situation a little bit closely. We've got somebody who is walking on land that has a 5-degree incline, and that incline over traveling wide distance over that incline, the vertical the vertical distance is x and the horizontal distance is 100. That's basically what's happening. And we're asked to calculate y and x. I'm going to redraw this triangle. I'm going to exaggerate the angle a little bit. I know that it's only a 5-degree angle, but I'll exaggerate the angle, make it a little bit larger so that we can, just write in it nicely. But you guys see the little picture over here. Okay, so here's the deal. Basically, we have a triangle where we've got an angle measure and we have two missing sides, a right triangle rather, with two missing sides. And our job is to calculate that. And so I use the old adage, you've got to use what you've got, and we have this side to get what you want. Let's try to get x first. So I have this side and x. Remember what we're dealing with? Remember how we're keeping in mind that anytime we're dealing with trigonometric relationships, we just write this SOHCAHTOA here. It helps us to memorize the relationships with what side. So what side deals with let's stand at angle 5 for a second. What side deals with the opposite and the adjacent? And if you come up here, this is opposite hypotenuse, adjacent hypotenuse, opposite adjacent. Tangent. Tangent is the function. I said what side? My bad. Tangent is the function that deals with opposite and adjacent. So what I know is, here's this relationship I can write. The tangent of 5 degrees is equal to x over 100. Stop for a second and feel like that's true. Like stop for a second and own that. And just because we're doing this, let me set us up for some more success. So if we're looking for y, that is that is the hypotenuse here. We still use what we've got, which is 100, to get what we want, y. So what trigonometric function deals with adjacent? That's how it is. This side is adjacent to angle 5 and hypotenuse, and we get cosine. So then we know that the cosine of 5 degrees is equal to, again, 100, this ratio 100 over y. So now it's a matter of us just solving for the variable that we want, because tangent of 5 is like a real thing. We can find the tangent of 5. We can find the cosine of 5. So what I would do is go over to Desmos. After I set up my situation so that it is, I'm going to call it calculator plugin ready, I'm going to go over to Desmos and solve. So watch this. Tangent of 5 is equal to x over 100. I want to solve for x. I remember looking at problems like this. It's like a proportion, right? I cross multiply, and when I do that, x times 1 is x, and tangent of 5 times 100 is whatever that is, 100 times the tangent of 5 degrees. And so make sure we're in degrees. We'll talk about that in a minute. So all I have to do to solve for x is multiply 100 times the tangent of 5. We'll let Desmos help us out with that. You can also use your phone calculators, but it depends on the keystroke and the step. And if you're using your phone calculator, you want to make sure to be in degrees aside instead of radians. Over here, we've got a little bit more of a tricky situation. In order to get y solved for a little bit quickly, I'm going to use a trick that I find really helpful. I don't like y in the denominator. I find it easier if y is not in the denominator. So what I'm going to do is I know that if I've got two ratios that are equal, their reciprocals are equal as well. Meaning if I flip them both, they're still equal. And that makes a certain symmetric sense, I think. And we could talk about the proof of that. And now when I cross multiply, I get y times well, not even cross multiply. At this point, I want y alone. Who's bothering y? That's 100. So I'm going to multiply both sides by 100. So when I multiply both sides by 100, notice I get y alone, and I have y is equal to 100 divided by the cosine of 5 degrees. Again, this is now, I'm going to call it calculator ready for me to just plug it into my calculator and solve. So now let's go over to Desmos. So here we are in Desmos, and watch what I do. I go over to this little wrench. I hope you can see it on my screen. I click on it and I make sure I'm in degrees. You must do that when you are dealing with these types of right triangle trigonometric relationships. And that'll change later on because we'll talk about radians. Well, you will in a later class, probably not with me. All right, so now let's see how we can calculate our answers. I go back here, I say, okay, I need to answer this. X is equal to 100 times the tangent of 5. And so I go and I calculate that. 100 times, and so where is the multiplication and where is the tangent? We can use that symbol, which is the little asterisk on your computer, and then tangent of 5 degrees. Your calculator will recognize that just by typing in tan. There's a place for functions, and I'll show that to you at a later time. But tangent of 5, there you've got it there. Let's go ahead and do the other one. So the other one was, let's go back. The other one was 100 divided by cosine of 5, and so we'll go and take care of that as well. So 100 divided by cosine, cosine of 5, and we have 100.38. So these are my two answers. The height, the vertical displacement is 8.7, I'm going to say 75, and the horizontal displacement, or well, actually the hypotenuse there would be 100 point, let's say 100.4, 100.38. And so let's go ahead and write those answers in. So this is about 100.38, and this one was 8.75, and this is all in feet. All right. All right, so I hope that made sense. Let's go on to another example. We're going to talk about inverse trigonometric ratios, and basically what that does is, let's see if we can get some of this. I know that the sine of some angle is equal to x, then the inverse of x is equal to the measure of that angle. That's the power of what we're going to do today. And what I need you to know, this little bit of information is important. Usually, you remember in algebra, we talked about taking a variable to the negative 1 power is equal to 1 over that variable, or any number to the negative 1 power is equal to 1 over that number. When we write a function and we write to the negative 1 power, it does not mean 1 over that function, all right? That's what's happening. What this means is the inverse function, so I'm calling it the opposite. So here, remember how sine of A gives me some value? Then the inverse sine of X gives me that A value back. It'll make more sense as we do a few examples. So let's check this out. Here in example 4, we're going to find the angle measure using inverse trigonometric ratios. Again, we use what we got to get what we want. We're supposed to find angle A. So here's angle A. Technically, I'd be standing here up at angle A. And so I see that I'm given these two lengths here. I'm given this side and this side. I've got to use what I've got, these two sides, to get what I want, angle A. What trigonometric function? Still SOHCAHTOA reigns. SOHCAHTOA. So what trigonometric function in relationship to A would use the sides relating to A as opposite and hypotenuse? Opposite and hypotenuse. And that would be sine. So I'm going to write this down. The sine of angle A, which is what we're looking for, is equal to opposite over hypotenuse, 18 over 27. Of course, I can reduce that. I'm just feeling like reducing is like totally like, just do it. It's really 2 over 3 because 9 divides into both of them. So, and remember, since it's a ratio, it's definitely reducible. You could have left it as 18 over 27, but you know, I'm being a bit of a nerd today. So sine of A is equal to 2 over 3. And so what I want to know is what A is. But according to that law we saw, we know that the inverse sine of 2/3, I'm starting with the ratio and I'm going to get the angle, is equal to A, the inverse sine of 2. So this is how inverse relations work. And now after this is just calculator work. Let's go to Desmos. So I totally hope you're seeing all of this. Down here in the corner, you see the keyboard. option. And so basically, if you click on it, you get to kind of use more of a traditional calculator by clicking on your by using the screen as your calculator buttons. Over here it has functions, and you'll see here it has your trig functions, sine, cosine, tangent. There are other ones called cosecant, secant, and cotangent, which relate to these guys. They're actually reciprocals. We'll discuss later, or if we don't, I want you to just know that. And then here we have other functions, which are the true inverses. So remember, I need the sine inverse. Oh, let me get this off because I don't need it there. I need the sine inverse. So what I'm going to do is I'm going to go straight to that function key and click on sine inverse. And now all I have to do is write that ratio in. And so remember, we had, what was it, 18 over 27? And I did that on purpose because I know we changed it to a different thing. I just want some of my naysayers to say, yes, it's okay. Notice it's the same thing. 18 over 27 yields an angle of 41.8 degrees. 2 over 3, that ratio, because it's the same ratio, leads to the same angle. And again, you need to make sure that you're in degrees when you're doing this. So sometimes you might get something that looks weird, and that might be because you're not in degrees. So keep in mind that that's important. So we got 41.8 degrees. Boom. There we go. Not too bad. All right. Let's look at this last example. This last example asks us to solve a right triangle. So in mathematical terms, when we talk about solving a triangle, what we're referring to is giving all the information about it, all the side lengths and all the angle lengths. And so we've been using SOHCAHTOA so far, all of our trigonometric ratio relationships. So let's make sure and write that down here. And so solve the right angle triangle, round side measures to the nearest tenth, and angle measures to the nearest degree. So we've got two sides of a right triangle. How can we find the third? You guys know this. You would use probably Pythagorean theorem, right? So that's one part of solving. So one part of solving is we need to get, let me highlight the things we need to get. We need to get this side here. We need to calculate what that is. And we need to calculate this angle here and this angle here. So we got three things to do in order to solve the triangle. So let's talk about what things. So one thing we could do here is Pythagorean theorem, which is totally legit. So let's do that. 5 squared plus 9 squared equals xy squared, right? And then so if we do our math and party on like we know we can, we get that that side squared, or the hypotenuse squared, is equal to 74. And so that tells me that the length is going to be the square root of 74. Since they asked us to round the side measures to the nearest tenth and angle measures to the nearest degree, this tells me that I need to involve a calculator. And so I'm going to use Desmos and see that the square root of 74 is 8.6. So side length xy is 8.6. All right, groovy. So one part done. Now let's get these angles. To find the measurement of the angle, again, I like to use what I've got to get what I want. And so that means I have here this side 5 and this side 9. What is that in relationship to angle x? That's what I want to ask myself. And when I observe that we've got the opposite over adjacent, this is adjacent, right? Because it's next to that angle. I know that I'm dealing with tangent. So the tangent of x is equal to opposite 9 over 5. And since we're in the business of finding angles, let's check out what's going on with y. So y, I have the opposite and the adjacent again. So that tells me I'm going to use tangent. So the other angle will be found. Let me get rid of this work here. Make it a little tinier and scoot it over. Okay, so the tangent of y is what we'd be looking at here, right? Tangent of y is equal to 5 over 9. So basically what we need to do in both of these in order to solve for y is to be using the inverse tan. And so we get these two situations that we're going to solve using Desmos. So let's go over to Desmos. So there we have it. I calculate the inverse tangent of 5/9. I get 29 degrees. And then I calculate the inverse tan of 9/5, and I get approximately 61 degrees. And so y is approximately 29 degrees and x is approximately 61. Let me know if you have any questions. I'll talk to you soon, guys. Bye.